在2025年 ，NASA 及全球其他国家的航天机构将进行一系列重要的太空探索任务，涵盖了月球探测、宇宙观测和小行星采样等多个领域。此次报告将详细介绍这些任务的背景、目标和时间线。主要任务概述：一、月球探测。阿尔特弥斯计划 NASA 将继续推进其阿尔特弥斯计划，计划于2025年进行数次月球登陆。其中 Firefly Aerospace 的蓝色幽灵任务将携带10项 NASA 科学和技术仪器，打算在月球的 Mare Crisium 地区着陆，进行为期2周的科学数据收集。日本的韧性任务，日本公司 ispace 将发射其韧性着陆器和微型探测车，目标是月球的 Mare Frigoris 地区，预计将在蓝色幽灵任务后的4到5个月内着陆。该任务旨在探索该地区的地质特征和资源。Intuitive Machines 的南极任务 Intuitive Machines 计划在未来几周内发射其最新的月球着陆器，目标是月球南极地区进行土壤采集和科学实验。2、宇宙观测。SPHEREx 空间观测站 NASA 计划于2025年2月发射 SPHERex 空间观测站，该任务旨在以光学和近红外光绘制整个天空，观察超过1亿颗星星，并寻找生命的迹象，包括水和有机分子。该任务的目标是提供有关宇宙形成和演化的重要数据。3、国际合作与竞争。中国的 Tianwen-2 小行星采样任务，中国计划于2025年发射其首个小行星采样任务 Tianwen-2， 该任务将与近地小行星 Kamo'oalewa 会合，采集样本，并计划在2026年将其带回地球。这一任务将标志着中国在小行星探测领域的一大进展。印度的载人航天计划，印度的航天计划也在2025年取得进展，计划发射宇航员前往国际空间站，并希望在2026年实现首个自有载人飞船的发射。4、商业航天。VAST 的商业空间站 Haven-1， 加州初创公司 VAST 的计划于2025年8月前后发射其首个商业空间站 Haven-1， 旨在为宇航员提供为期30天的任务。Haven 亦将最初作为独立的空间站运作，未来计划与其他空间站模块连接。共同要点与差异。共同要点：所有参与机构都强调2025年将是一个充满雄心壮志的太空探索年，涉及月球、宇宙观测和小行星研究。各国在太空探索中的竞争与合作日益明显，尤其是中国、美国和印度在载人航天和探测任务上的进展。差异： NASA 的计划更侧重于科学任务和技术创新，而其他国家如中国和印度则强调其独立的航天能力和目标。时间线：2025年1月 SPACEX 发射蓝色幽灵任务与日本的月球着陆器。2025年2月 NASA 发射 SPHERex 任务。2025年春季，印度宇航员前往国际空间站。2025年夏季 VAST 公司发射其商业空间站 Haven-1。2025年春季，中国发射 Tianwen-2 小行星采样任务，目标 Kamo'oalewa。结论：总结来说，2025年将是太空探索的关键一年。NASA 与全球各国的航天机构将通过多样化的任务推动人类对太空的理解和探索。这些任务不仅展示了各国在太空领域的技术进步，也强调了国际合作与竞争的重要性。全球各国在探索宇宙的道路上将携手并进，迎接更多的未知挑战与机遇。
The NASA 2025 plan is characterized by a series of ambitious missions that showcase both collaboration and competition in space exploration. Here are some counterintuitive insights drawn from the various missions planned for that year. 1. Commercial Lunar Payload Services (CLPS). While NASA is a government agency, its reliance on private companies like Firefly Aerospace and Intuitive Machines for lunar missions indicates a shift towards privatization in space exploration. This reliance on commercial entities might seem to dilute NASA's role, but it actually enhances its capacity to conduct more missions simultaneously, leveraging private innovation and cost efficiencies. 2. International collaboration versus competition. Although there is significant competition between nations like the US and China regarding lunar and asteroid missions, there is also a strong element of cooperation. For instance, NASA's Artemis program is not solely a US initiative, it has international partners contributing to various aspects of the program. This duality of competition and collaboration is a notable trend in contemporary space exploration, where countries are both rivals and allies. 3. China's rapid progress. China's plans for a successful asteroid sampling mission Tianwen-2 juxtaposed with recent U.S. setbacks in astronaut missions as seen with Boeing's Starliner issues highlight a counterintuitive aspect. While the U.S. has historically been viewed as the leader in space exploration, China is rapidly closing the gap and may even overtake the U.S. in certain areas of space capability. This shift challenges the long-held perception of U.S. dominance in space. For India's human spaceflight program, India's ambitions to send astronauts to the International Space Station ISS might not be as widely recognized as those of the US or China. Yet it demonstrates that emerging space nations are making significant strides. The fact that India is on the verge of launching its own crewed spacecraft contrasts with earlier assumptions that only established spacefaring nations could achieve such milestones. 5. Focus on astrobiology. The SPHEREx mission aims to find signs of life by looking for water and organic molecules across the Milky Way. This mission's focus on astrobiology is counterintuitive given the vastness of space and the challenges involved in detecting life beyond Earth. It underscores a growing belief among scientists that understanding life's ingredients in various environments can provide insights into the potential for life elsewhere, even if direct evidence remains elusive. 6. Commercial space stations. The launch of Vast's Haven 1, a commercial space station, signifies a shift in the paradigm of space habitation. This development is counterintuitive to the idea that only governmental agencies can build and manage space stations. It suggests a future where commercial entities may play a significant role in human activities in low Earth orbit, potentially leading to a more vibrant and competitive space economy. 7. Differing missions timelines. The staggered timelines of various missions, such as Blue Ghost landing in early 2025 and Japan's ispace mission months later, illustrate a strategic approach where multiple entities are working towards similar goals but on different schedules. This fragmentation may seem inefficient but allows for risk mitigation. If one mission fails, others may still succeed. 8. Lunar South Pole versus Mare Crisium. The varied landing sites chosen by different missions, some targeting the lunar South Pole while others aim for Mare Crisium, reflect a broadening of scientific interests. This diversity counters the notion that lunar exploration is homogeneous and indicates a rich variety of scientific questions that can be addressed through different geological contexts. 9. The role of non-governmental entities in science. The increasing involvement of private companies in scientific missions such as the Blue Ghost carrying NASA's instruments challenges traditional views of science as strictly a governmental endeavor. It raises questions about the future of public-private partnerships in space exploration and how they might redefine scientific discovery. 10. Asteroid missions as a new frontier. The planned missions to asteroids, particularly China's Tianwen-2, emphasize a growing recognition of asteroids not just as potential threats but as valuable sources of scientific information and resources. This shift in perception might seem surprising given past focus primarily on planets and moons, highlighting a dynamic understanding of our solar system. In summary, the NASA 2025 plan reveals a multifaceted approach to space exploration that incorporates commercial partnerships, international collaboration, and a diverse array of scientific missions. The interplay between competition and cooperation alongside the evolving roles of various stakeholders in space presents a counterintuitive landscape that challenges traditional notions of what space exploration entails. The NASA 2025 plan outlines a series of ambitious space exploration missions that will take place in the coming year, emphasizing both the agency's initiatives and the broader landscape of international space efforts. While the main highlights of the plan, such as lunar missions, a new cosmic observatory, and asteroid sampling, are well documented, there are several important aspects of this report that are often overlooked, yet they are significant for various reasons. Significant overlooked aspects. 1. Commercial Lunar Payload Services (CLPS) initiative. The involvement of private companies like Firefly Aerospace and Intuitive Machines in lunar missions under NASA's CLPS is a critical component of the agency's strategy to advance lunar exploration. While the media tends to focus on the missions themselves, the significance lies in how this initiative is transforming NASA's operational model. By outsourcing certain missions to commercial partners, NASA is not only reducing costs but also fostering a competitive environment that could lead to innovative solutions and technologies in space exploration. This shift towards commercialization represents a fundamental change in the relationship between government space agencies and private enterprises, which could shape the future of space exploration. 2. The role of international competitors. The report highlights the advancements made by countries like China and India in space exploration, particularly with China's Tianwen-2 asteroid mission and India's plans for its crewed spaceflight. The significance of this international competition cannot be overstated. It showcases how global space exploration is becoming a strategic arena for technological advancement and international prestige. The growing capabilities of nations like China and India may also drive the U.S. to increase its investment in space technology and exploration, thereby influencing global policy and collaboration in space activities. This competitive landscape could accelerate the pace of discovery and technological innovation. 3. SPHEREx mission's broader implications. The SPHEREx mission, aimed at mapping the entire sky, is not just about gathering data. It represents a significant leap in our understanding of the universe. This mission is expected to yield insights into the formation of galaxies and potentially identify signs of life such as water and organic molecules. The significance of SPHEREx goes beyond its scientific goals. It reflects a broader ambition to understand our place in the universe and the potential for life beyond Earth. The findings from this mission could have profound implications for astrobiology and our understanding of fundamental cosmic processes. 4. Human spaceflight and international cooperation. The planned human spaceflight missions, particularly India's collaboration with Axiom Space, illustrate a burgeoning trend of international cooperation in space exploration. This is significant because it highlights how countries are increasingly working together in the realm of human spaceflight, which has traditionally been a domain of national pride and competition. Such collaborations can lead to shared knowledge, resources, and technology which ultimately benefit the global community. The success of these missions could pave the way for more extensive international partnerships in future space endeavors, including the establishment of permanent human presence on the Moon or Mars. 5. Impact of private space stations. The launch of commercial space stations like Vast's Haven 1 signifies a new era in human activities in low Earth orbit. While most discussions focus on the technical aspects of these stations, the broader implications include the potential for private enterprises to lead in space habitation. This shift could reduce dependency on government-funded ISS programs and allow for more diverse activities in space, including research, tourism, and manufacturing. The emergence of private space stations could change the economic landscape of space activities, making them more accessible and sustainable in the long term. 6. Environmental and societal considerations. The report discusses various scientific endeavors that may contribute to our understanding of Earth and the universe, yet it often overlooks the environmental implications of space exploration. As missions aim to gather more data about celestial bodies and their composition, there is an opportunity to reflect on how these activities can inform our understanding of Earth's climate and ecosystems. The interface between space exploration and environmental science is becoming increasingly relevant, particularly as Earth faces challenges like climate change. Understanding how space missions can be leveraged to address earthly concerns could be a critical area for future research and policy development. Conclusion: the NASA 2025 plan is more than just a roadmap for upcoming missions. It represents a pivotal moment in the evolution of space exploration, encompassing commercial partnerships, international competition, and the interplay between science and societal needs. By recognizing these often overlooked aspects, stakeholders can better appreciate the implications of NASA's initiatives and the broader context of global space exploration. These dimensions are significant not only for their immediate scientific and technological contributions but also for their potential to shape future policies, collaborations, and the very fabric of human endeavors in space. The 2025 NASA plan encompasses a range of ambitious missions that reflect significant advancements in space exploration. Here are 4 valuable points for in-depth analysis and discussion. 1. Lunar exploration and the Artemis program. NASA's continued commitment to lunar exploration through the Artemis program is a cornerstone of its 2025 plan. The upcoming missions, including the Blue Ghost mission by Firefly Aerospace, highlight a shift towards utilizing commercial partnerships to achieve scientific objectives. This initiative not only aims to land on the Moon's Mare Crisium but also involves multiple international players such as Japan's ispace, which plans to land in Mare Frigoris. The collaborative nature of these missions underscores the importance of international cooperation in space exploration and can lead to a discussion on how such collaborations can benefit scientific research and technological advancements. Additionally, the Artemis program is pivotal for future human missions to Mars, making this lunar exploration a foundational step in NASA's broader goals. 2. Advancements in cosmic observation with SPHEREx. NASA's SPHEREx mission, set to launch in February 2025, represents a significant leap in our capability to observe the universe. By mapping the entire sky in optical and near-infrared light, SPHEREx will investigate over 100 million stars and search for signs of life, including water and organic molecules. This mission aims to provide insights into galaxy formation and the origins of the universe. The implications of such a mission extend beyond just astronomy. It raises questions about the potential for discovering extraterrestrial life and how such findings could impact humanity's understanding of its place in the cosmos. The discussion could delve into the technological innovations required for such observations and the philosophical implications of discovering life beyond Earth. 3. International competition and cooperation in space. The 2025 plan illustrates a complex landscape of competition and cooperation among global space agencies. China's Tianwen-2 mission to collect samples from the asteroid Kamo'oalewa, alongside India's human spaceflight ambitions and their planned missions to the International Space Station (ISS), highlights a rapidly evolving space race. This scenario presents an opportunity to analyze the geopolitical dynamics of space exploration, including how nations balance collaboration on projects like the ISS with competitive ambitions in asteroid mining and lunar exploration. Furthermore, the involvement of private companies like VAST in launching commercial space stations adds another layer to this discussion, emphasizing how commercial interests are shaping the future of space exploration. 4. The role of commercial space ventures. The increasing role of commercial space ventures, exemplified by companies like Firefly Aerospace and VAST, signifies a transformative shift in how space exploration is conducted. NASA's Commercial Lunar Payload Services program shows a strategic pivot towards harnessing private sector innovations and efficiencies. This trend raises critical questions about the sustainability of space exploration, the potential for commercialization of space resources, and the regulatory frameworks needed to manage these new ventures. Analyzing the impact of private companies on traditional space missions can lead to discussions about the future of human presence in space and the ethical considerations of commercializing extraterrestrial environments. In conclusion, the 2025 NASA plan not only marks a pivotal year for space exploration but also opens avenues for extensive discussions on collaboration, technological innovation, and the evolving landscape of global space endeavors. Each of these points emphasizes the multifaceted nature of modern space exploration and the implications it holds for science, international relations, and the future of humanity in space. 1. Apollo 11 Moon Landing 1969. This historic mission marked the first time humans landed on the Moon. Astronauts Neil Armstrong and Buzz Aldrin became the first and second humans to set foot on the lunar surface, while Michael Collins orbited above in the command module. The mission was a pivotal moment in the space race, showcasing U.S. technological prowess and ambition in space exploration. 2. Voyager Program 1977. NASA launched the Voyager 1 and Voyager 2 spacecraft to explore the outer planets of our solar system. Voyager 1 provided humanity with the first close-up images of Jupiter and Saturn, while Voyager 2 became the only spacecraft to visit Uranus and Neptune. The missions revolutionized our understanding of the solar system and continue to send data back from interstellar space. 3. Mars Exploration Rovers 2004. NASA's Mars rovers Spirit and Opportunity landed on the Martian surface in January 2004. Their primary mission was to search for signs of past water and assess the planet's habitability. Opportunity far exceeded its expected lifespan, operating until 2018, and provided valuable data that has shaped our understanding of Mars and its geological history. In 2025, NASA and various international space agencies are set to undertake a series of ambitious space exploration missions that will significantly enhance our understanding of the Moon, the universe, and beyond. This year promises to be pivotal in the realm of space exploration, showcasing both national and international efforts toward expanding our cosmic frontiers. Key missions overview. 1. Lunar exploration. NASA's Artemis program will be at the forefront with several missions planned for lunar landings. The Blue Ghost mission by Firefly Aerospace aims to land in the Mare Crisium area, carrying 10 NASA scientific instruments for 2 weeks of data collection. Japan's ispace will follow with its Resilience lander and micro-rover targeting Mare Frigoris, set to touch down approximately 4 to 5 months after the Blue Ghost mission. Intuitive Machines plans to launch its next-generation lunar lander to the Moon's south pole, equipped with tools to extract soil and conduct experiments. 2. Cosmic observation. The SPHEREx space observatory is slated for launch in February 2025. This mission will map the entire sky in optical and near-infrared light, observing over 100 million stars and searching for signs of life such as water and organic molecules in the Milky Way. 3. International collaborations. China's Tianwen-2 mission aims to rendezvous with near-Earth asteroid Kamo'oalewa, collect samples, and return to Earth by 2026. This mission underscores China's advancing capabilities in space exploration. India is set to send astronauts to the International Space Station (ISS) and develop its crewed spacecraft, with hopes for its first launch in 2026. 4. Commercial ventures. The startup VAST will launch its commercial space station Haven 1 in mid-2025. This station will initially function independently and is designed to house astronauts for up to 30 days, with plans for future expansions. Trends and predictions. Increased international collaboration and competition. The year 2025 will see heightened collaboration among countries alongside competitive advancements, especially among the US, China, and India. This dynamic is likely to lead to shared missions and data exchange, fostering a global approach to space exploration. Emergence of commercial space ventures. The trend of commercial involvement in space exploration is set to grow, with companies like Firefly Aerospace, Intuitive Machines, and VAST leading the charge. This shift may democratize space access and accelerate innovations in technology and research. Focus on astrobiology and cosmic origins. With missions like SPHEREx and lunar explorations, the quest to understand the origins of life and the universe will gain momentum. The data returned from these missions could provide critical insights into how life might exist beyond Earth. Technological innovations. The missions planned for 2025 will likely drive advancements in space technology, including improved spacecraft designs, landing technologies, and instruments for scientific research. These innovations will have broader applications beyond space exploration. Public engagement in science. With a series of high-profile missions, public interest in space exploration is expected to rise. Initiatives to involve citizen scientists and educational programs will likely expand, encouraging a new generation to engage in STEM fields. Conclusion. The landscape of space exploration in 2025 is poised for transformative developments driven by NASA, international space agencies, and private companies. This year will not only enhance our understanding of our celestial neighbors but also pave the way for future generations to explore and potentially inhabit other worlds. The collaborative and competitive spirit of this era of space exploration will inspire innovations that could benefit humanity on Earth and beyond.